All right, now we're going to start chapter 3 talking about parallel and perpendicular lines. So first, let's start by defining the various types of lines that we're going to have. First type are parallel lines, and parallel lines are lines that do not intersect but are coplanar. So lines N and lines M in our little diagram here, and we see they've got these little red triangles on them, and that means that they are parallel to each other. So that means no matter how long they go out, and we know they stretch to infinity, they will not cross. Okay, so let's get rid of that. Next are skew lines, and skew lines do not intersect and are not coplanar. So what does that mean? So here we have line K, and over here we have line M. And they're going to pass each other like ships in the night, but they're not going to touch. That's skew. Line K is not on the same plane as line M, and yet they do not intersect. And then parallel planes, two planes that do not intersect are parallel planes. So planes T and planes U are parallel. Think of them like the floor and the ceiling. You can stretch them out forever and they're never going to touch each other. So let's look at some examples and talk through them. So let's find a line parallel to line CD, which is this guy right here, and contains point A, which is right here, is this corner of the box. So if we think about just the parallel lines for 1 second, what appears that this will be parallel, this one will be parallel, and this one will be parallel. But only one of them contains point A, and that's line AB. Next one, lines skew to CD and contains point A. Well, what does skew mean? Skew means that they're going to crisscross but never touch. So DE touches, CF touches, even though they're not coplanar. BG is skew, and AH also skew, but it's the only one that contains point A. So that's the one that satisfies our condition. All right, lines perpendicular to line CD and contains point A. Well, this little box here means perpendicular, and that is this guy here. So we're going to have line D. A is perpendicular and contains point A. Then a plane parallel, let's switch over to green, the plane EFG. EFG is right here. It's the bottom of the box. So what's going to be parallel? Well, the top of the box. So we have plane ABD or DAB or CBA, any combination of those that contain the top of the box. So pause the video and do this section with the parallel, skew, perpendicular, and parallel planes containing point F, and then come back and we'll work through it together. All right, welcome back. So GH is our starting point here. Point F is over here. We want it parallel. So that is going to be line EF. All right, so line skew to GH and contains point F. Well, skew is not on the same plane, so it's got to be going in a different direction. So it's going to be line BF. Line's perpendicular. Well, here we don't have the little box, but we do have the word appears to be. So we can look and we can kind of guess. So that is going to be this one right here, line FG. And when you're solving these, you always want to include the point in your answer, because then you know you got it right and the person grading it knows that you know. All right, planes parallel to plane GHD, that's this side of the box. So what's going to be parallel plane the opposite side of the box? So we're going to do plane BFE. All right. So let's identify some of this stuff. Let's look at just identifying the lines when they start crisscrossing and being a little messier. All right, so two lines in the same plane are either parallel, like point N and L, and like we said earlier, these little arrows mean that they're parallel, and sometimes there'll be two arrows, and ones go with ones, twos go with twos. So on the same plane, all the lines, the infinite number of lines, they are either parallel or they intersect at exactly one point, like line J and line N, which intersect right here at point P. All right, so given that, let's talk about a point not on a line and a line. So through a point not on a given line, there are infinitely many lines, more lines than we can count. Exactly one of them is parallel, and exactly one of them is perpendicular to the given line. So let's look at what that means. So there's a point, there's a line and a point not on the line. There's exactly one line through the point parallel to the given line. This is our parallel postulate. So let's draw point P and a line L. So we are going to have through point P exactly one line that's going to be parallel to point L. One line and only one line. One line and only one line. And that's our parallel postulate. Well, let's look at our perpendicular postulate. Well, just like the parallel postulate, if there's a line and a point not on the line, there's exactly one line and only one line through the point perpendicular to the given line. So what does that look like? Let's get our point and our line L. And let's draw a line through P that is perpendicular. Can only be one. If we have more than one, we did something wrong. All right, so let's look at a couple of real-world examples. So let's name a pair of parallel lines. Excuse me. So here we got arrows, and here we got arrows. We have two, and like I said earlier, ones go with ones, twos go with twos. So our parallel lines are going to be line MD and line EF, and we're going to write it like this, because this means parallel. Let's look at the perpendicular lines. And what are we looking for perpendicular lines? That box right there, which means it's a right angle, which means they're perpendicular. So we got line BF or BM is perpendicular to line AD. That upside down T means perpendicular. All right, so last question is FE, right here, parallel to AC. Well, while we can clearly see that it is not, that they will intersect, that's not the full answer. Because this is geometry, we have to use our rules. So no. So line MD is parallel to line FE. And only one line through M can be parallel to line FE. So that's the real answer. By our parallel postulate up here, there's a line, a point, not a line, there's exactly one and only one line through the point parallel to the given line. Well, here DM is parallel to FE, so no other line that goes through point M or point D can be parallel to FE. Not possible. That's our rule. And since it's a postulate, we're not proving it, and we can't break it. So let's look at, let's do another example. Same sort of thing. Actually, why don't you try this on your own, pause the video, and then we'll look and see how you did. All right, let's see how we did. Name a pair of parallel lines. Well, here we got arrows, so we know line GK is parallel to line HL. Now we want perpendicular lines. Well, we got a box here, means a right angle. So line GK is perpendicular to line LN and is GN perpendicular to JL. GN is right here. We already know GK is perpendicular to LN, so very similar to the one we had above, talking about the parallel lines. No line GK is perpendicular to JL, and by the perpendicular postulate, only one line through G is, oh, I should spell it right, perpendicular to line JL. Good work. So let's move to the next thing, which is going to let us really build out the information we have and what we can do with it. So identifying pairs of angles. So a transversal is a line that intersects two or more coplanar lines at different points. Well, what does that mean? Well, here we have a line M, and over here, we can do a better line than that. We have line N, and we have a line L that intersects the other two lines. So line L is a transversal. Well, why do we care? Great question. And the answer is that this lets us identify angles, which we'll see later gives us a lot of power. So let's look at the set, let's break them down, and then we'll go from there. So two angles are corresponding angles when they have corresponding positions. So that means same side of the transversal, same relative side to the lines. So here's 2 and 6. They're both on the right side of the transversal, and they are above the lines. That's corresponding. The next kind are, they are alternate, got ahead of myself, alternate interior angles. So they alternate, which means they change sides of the transversal. Interior means inside, so change sides between the lines. Then we have alternate exterior angles. They are alternate, they change sides of the transversal. Exterior means outside, so outside the lines, changing sides of the transversal. And then the last type that we're going to have that matter to us are consecutive interior angles. And consecutive means next to each other, like 1, 2, 3 are consecutive integers. Angles 3 and 5 are next to each other. They're looking at each other. You can think of it like a goalpost. So these are the angles we're going to work with when we have transversals. So let's work on identifying the pairs. So all the pairs of angles of the given type corresponding. Same side of the transversal, same relative side of the lines. So here our transversal is right here. So same side, same relative position to the lines. So angle 1 and angle 5. Angle 2 and angle 6. Angle 3 and angle 7. Then angle 4 and angle 8. You can see same side of transversal, same relative, both above or below the lines that we're intersecting. Okay, now alternate interior. And the words tell you what to do. Alternate changes sides, interior inside the lines. So we get angle 2 and angle 7, angle 4, and angle 5. Alternate exterior, outside the lines, crosses the transversal. So angle 1 and angle 8, angle 3, and angle 6. Then the last one, consecutive interior, inside our goalposts. So we get angle 2 and angle 5, angle 4, and angle 7. The names tell you what to do. So let's classify these angles. So we got 1 and 5. First thing, let's identify our transversal, which is right here, our pink line. Same side of the transversal, both to the left. So that's going to be corresponding angles. Let's identify our transversal again. One line goes through 2. Okay. Let's see. Opposite side, so we know they alternate. And both outside the lines, so they are exterior angles. And the last one, change sides of the transversal, so they alternate between the lines, so they are interior angles. Keep it simple, and you'll always get it right. All right. Oh my goodness, there's a lot going on here. So what we have here is we have 3 lines all crisscrossing each other. So which line is our transversal? Well, it depends. So if we want to look at what is angle 1 and angle 7, let's look at the line that connects them. So this is going to be our transversal in this instance, which will make them alternate exterior angles. What if we want to deal with angle 8 and angle 10? Well, 8 and 10 is going to make this line our transversal. So both between the lines on the same side of the transversal looking at each other, we can make a kind of a goalpost. So they are consecutive interior angles. And then what if we want angles 9 and, oh, let me change that. That's not what I want. Let's make it angle 1 and angle 12. Well, what line connects 1 and 12? 1 and 12 is right here. So they're on the same side of the transversal, right? We got 1, we got 12. So it can't be alternate. So it's either corresponding or consecutive interior. Well, they're not looking at each other. We can't make a goalpost. So they're not consecutive interior, but one is above the line and one is below the line. So they are not corresponding either. So they don't fit any one of our 4 rules. So they have no relationship. So remember, when you're looking for, they got to match the rules and find what your transversal is. And we are done.